In this video, we're going to work example problems related to functions and relations. So let's get started. For these initial problems, we want to determine if the relation defines y as a function of x. So remember, every single function is a relation, but not every relation is a function. So when it comes to relations, the fundamental way we study relationships between two or more variables is using relations, which are just a list of, so if we're studying the relationship between two variables, a relation in two variables would be just some group of ordered pairs. 1, 2, minus 1, 3, 5, minus 7, etc. Maybe you have a finite group of these ordered pairs, or maybe you have an equation which represents an infinite number of ordered pairs. So here you can choose an x, solve for y, choose another x, solve for y, choose a y, solve for x, and you get these ordered pairs. If you're studying the relationship between three variables, then it's this list of these triplets. It's a group of these ordered triples. Okay, so that's what a relation is, this group of points, right? Because if you have two or more parameters, like you can plot this in the 2D plane. If you have a triple like this, you can plot this in a 3D plane. But even abstractly, you can think about plotting this in 4D. If you're studying the relationship between four variables, you have a group of points like this. You can call these points. Okay, so now if we're studying the relationship between two variables, and we're asking, does the relation we're looking at between two variables define y as a function of x? So we're asking, is this relationship in two variables a function? But when you ask if a relation is a function, you have to be clear on what you're regarding as the inputs and what you're regarding as the outputs. So in this case, they're saying that y, the vertical axis, is a function of x, the horizontal axis. So x is the inputs, y are the outputs. Well, and when it comes to a relation, determining if a relation is a function, the criteria is that there can't be the same input mapping to two or more outputs. That can never happen anywhere. If that doesn't happen, then the relation is a function. If it does happen, then that relation is just a relation, it's just not a function. Every function is a relation. So, okay, now graphically, when it comes to if you have a relation in two or three variables, you can plot it graphically. And if we're thinking about any kind of Cartesian coordinate system, 2D or 3D, then we can use what's called the vertical line test to test and see if a function or a relation is a function. So there can't be any point in the entire plane where we draw a vertical line and it passes through more than one point. Well, there you go. It does. And all this test is doing is, since that happened, we can see that x is equal to 3, the input, corresponds to y is equal to 1 and y is equal to minus 2. That's the whole purpose of the vertical line test. So no, this is not a function. Now, we could also do this with a Cartesian coordinate system in 3D, because the convention is that you're going to put the output on the y-axis here, and the convention is that you'll put the output on the z-axis here for a relation in three variables. I guess you don't have to. I mean, if you had the output on the on the horizontal axis, then the vertical line test wouldn't work. The whole point is that you're just seeing for any input, you can draw a vertical line anywhere. If it's a vertical line, that means the output is constant along the vertical line, so it can't pass through the graph more than once if it's going to be a function. But this is not a function. Okay, here we can test to see if a relation is a function, but instead of graphically, just by examining the points. So this is a relation with 1, 2, 3, with 4 data points. Okay, so what we're looking for is, do we have the same input corresponding to different outputs? Well, no. Each input has one output. So this is a function. And you can see this is a good illustration of why in a lot of cases we work with functions, because we couldn't have Tom Hanks listed twice with two separate Oscar nominations, right? That would make sense. So, but yes, this is a function. Okay, here we have a graph where the output is on the vertical axis, input on the horizontal axis, vertical line test. This is like an equation. There's an infinite number of ordered pairs. So this is what you would think about as like an equation. No, there's no point here where there's no vertical line that would that crosses the graph at more than one point. So this is a function. Here, okay, that passes, that doesn't pass. So no, this is not a function. This is a function. This is if you have a continuous line graph like this, unbroken anywhere, it's not just points plotted like these distinct points, then it's an infinite. It's still a relation. This is just a group of ordered pairs. It's just an infinite amount of ordered pairs. This is the equation y is equal to 2. You can plug in any y value you want, and you're on the graph. Well, there's an infinite number of real numbers you can plug in here, right? There's an infinite number of, so the x coordinate is going to be whatever you want. It's going to be some number 2. So it's any real number here and the number 2 here. So it's an infinite number of points. It's just a group of points with any number you want here. Okay, is this a function? Well, okay, it seems, here it passes. Okay, but what about here? Well, the open circle means that there's no, the functions or the relation's not defined there. So it's still just passing through one point. So this is a function. There's nowhere where you can have an x that corresponds to two separate or two or more outputs. Okay, here's another way that we can visualize a relation with this mapping between like the x domain and the y domain. Is this a function? No, you've got the same input mapping to 4 separate outputs here. This is a relation, though. This is a relation. Remember, what is a relation? It's a set of a group of ordered pairs or ordered triplets, whatever. It could be a finite group or it could be an infinite group. This is the relation -8, 3, -8, 4, -8, 5, -8, 6. This is the relation right here. This is a relation in x and y. Okay. Let's see. Is this a function? So you've got 2 separate outputs mapping to the same input. That's fine. Well, first of all, let's just keep in mind they're saying y is a function of x, so x is the input, y is the output. You've got 2 separate inputs mapping to the same output. That's okay. You just can't have the same input mapping to more than one output. So this is a function. Okay, here's another way we can represent a relation, an equation form. Here, there's an infinite number of ordered pairs. You pick an x, solve for y. Pick another x, solve for y. Pick another x, solve for y. Or pick a y, solve for x. Pick another y, solve for x. But with an equation, x, the variables are placeholders for any number. And so there's an infinite number of numbers you can choose. So that's why it's an infinite number of ordered pairs or however, or ordered triplets, whatever, however many variables you have. So, okay, is this a function? How can we determine if an equation is a function? But specifically, to be specific, we're saying, is y a function of x here? Well, we can solve for y and see if we can have y by itself on one side of the equation, and then on the other side is just some expression of x with no pluses or minuses or anything like that, then it's a function. Because if you think about it, any expression in general, if you have any kind of expression, it doesn't matter if there's radicals in it. It doesn't matter doesn't matter what's in it. Because remember, a radical as it sits it's a principal nth root. Its outputs one number. Just a radical. If you just have a radical with no plus or minus around it, it's going to output one number. So if we've got an expression over here with just x's and y by itself over here, and there's no plus or minuses anywhere, it's a function. So let's solve for y. So we've got, let's see, y plus 5 squared, and then we've got 25, subtracting x plus 1 squared from both sides. Okay. So plus or minus. Okay. Okay, so we can't just input any x because what's under the radical here can't be negative, but it doesn't matter. We're going to have, for any x value that keeps this positive or 0, we're going to have two values. It's not going to be for any x input. There's not going to be just one and only one output for y. So no, this is not a function. And we actually know it's not because we know this is the equation for a circle. A circle centered at -1, -5, with radius 5. So 1, 2, 3, something like that. Well, no, that's not a function. Okay, is this a function? Yes, yes. We have y. Is y a function of x here? We have y by itself over here and just some expression of x with no y in it. And there's no pluses or minuses anywhere. So you're always going to get a unique value, one unique value for whatever x you plug in here. So yes, this is a function. Okay, is y a function of x here? Yes, you have y by itself on one side and just some expression of x on the other side with no pluses or minuses anywhere. It might seem like, well, no, there could be multiple outputs in certain situations, even though you don't have a plus or minus. No, it's only with the radical. Whenever you introduce it to solve an equation, you start putting these plus or minuses. A radical is like, okay, so for x to some positive integer power, there's no, you don't input an x and get multiple outputs. For x to a negative integer power, you don't input an x and get multiple outputs here. For x to a radical, x to a rational exponent, a radical, the whole purpose of the radical is it's making sure you only have one output. And then when we get to logarithms and exponentials, there's only going to be one output coming out of that. So if you've got y or a single variable by itself on one side, just by itself, and then all the other input variables in an expression on the other side without the output variable, and there's no pluses or minuses anywhere, anything that's obviously going to give more than one answer, it's a function of that variable that's alone. So yes, this is a function. What about here? Well, okay, we need to get y by itself. So we need to take the square root of both sides. This is still a principal root. This is still just one output. But because we introduced this, we put the plus or minus. Now, no, it's not a function. Because if we input x is equal to 9, the principal square root of 9 is just 3, but then there's a plus or minus in front of it. Okay, is this a function in terms of y is a function of x? Well, yeah, we can see that it's going to be because this y is by itself right here. So we can just do, now let's subtract x cubed from both sides and let's add you have y by itself in this big expression here, but there's no pluses or minuses anywhere. There's one output of this. One output of this. It doesn't matter. Dividing by 0, that doesn't mean anything. There's no, you can't get more than, without a plus or minus somewhere here or something else indicating there's going to be more than one value. You're never going to have multiple values coming out of an expression. So yes, y is a function of x here. Okay, so now for these problems, we want to determine if the relation defines z as a function of x and y. So in this case, the inputs are xy pairs, and the outputs are just the single z values. Okay, so you input an x like -2, 1, or 5 minus 11, or 7, 1. So you could think about if this was an equation, for example, an equation in 3 variables, it's like you'd be inputting an x and a y and then solving for z. Okay, so all right, so this xy pair maps to 5, this xy pair maps to 12. You don't have an xy pair mapping to 2 or more outputs. Yes, this is a function in terms of z is a function of x and y. Okay, what about this? Well, no, because look, we have the input 5, 13 mapping to 2 separate outputs, so no. Okay, what about this equation? Is this a function? Could we rewrite this way? Yeah. We have the output variable, because we're asked if is z a function of x and y. So we have the output variable by itself and just some expression with x and y on the other side. There's no z in this expression. Yes, this is a function of x and y. Okay, what about this? Okay, well, do we have a z mixed in here? You know, if there was a z inside the absolute value, well, we know with absolute values you get like these either or answers. So you wouldn't think if most likely if there was a z inside here, since there's multiple answers, then it probably wouldn't be a function. But there's no z in here. Okay, we've just got the z by itself over here. Well, we see we can do this. Z is equal to, and we can do y minus the absolute value. We can do that minus y squared. And there you go. Yes, z is a function of x and y. We just have this. There's no pluses or minuses anywhere. The absolute value, there's only one value that comes out of an absolute value. You never get multiple. Yeah, when you're solving an absolute value equation, that happens, but that's different. There's no absolute value expression to where you get more than one value out of that. Okay, now for these problems, we want to determine if the relation defines z and w as a function of x and y. So you have x, y pairs are the input, and the output is zw pairs. This is completely fine. You can input vectors and get an output vectors. That's like the way you look at x, y coming in as a vector, zw coming out as a vector. Well, you can't have two outputs to have a function. No, that's not what they're referring to. You can't. The input 513 cannot map to can't map to 1 minus 1 and 8, 5. The example we talked about was like for the shipping example. If the inputs are like weight of the package and the size of the package, like the volume of the package, that's the inputs. And the outputs is the cost to ship and the shipping time. The idea is you can't have the same weight and size package input mapping to a cost to ship of $7 and a shipping time of 3 days, as well as a cost to ship of $12 and a shipping time of 5 days. You can't map to two separate outputs. But as far as it can map to a vector that incorporates more than one output. That's different. So this is a function. This is a function. You don't have any input mapping to two separate outputs. You have two separate inputs mapping to the same output. That's fine. You could have potentially a package that weighs this much and has size this much, mapping to $5 shipping with 3 days shipping time, and some other weight size combination also mapping to $5 shipping and 3 day shipping time. That can happen. Okay, is this a function? Yes. Every single input is mapping to its own unique output. But more specifically, there's no single input mapping to more than one output. Okay, for these problems, we want to evaluate the function for the given value of x. So what is g of 3? And here's g of x. What is g of 3? Well, okay, let's first remember what function notation is. It's just a very useful notation that you can use since you've got this variable on one side by itself in an equation. And then since you can put it into that form with the other side just being equal to the input variables, then you can write it with this like machine notation here. Like, okay, so here you've got y is equal to x squared plus 3x. Well, since this is a function, y is a function of x, you have you can write it like this if you want. And it's like a machine. You input an x, and then it's going to give you an output. If you had z is equal to x squared minus y squared, well, you can write this as f of x, y. It's just interesting because you think about it, it's like a tool in your toolbox that you can pull out of the toolbox and use. If you do MATLAB codes, when you create MATLAB functions, you name the functions whatever you want. Like I could, this is the A-Bear engineering function. You name it, and it has a certain name, and you give it the inputs, and it outputs something to you. And we'll see in the section at the end of this chapter how you can the composition of functions, and you can combine functions and whatnot, and it's really interesting. So function notation is very useful. if you want to use it. Okay, so what is g of 3? Well, all you're doing is you're just, okay, you're evaluating the function, the expression on the other side with the x variable equal to 3. So g of 3 is 1 over 3. That's it. What is g of 1/3? Well, that's just 1 over 1/3. 3. What is k of minus 5? So k of minus 5 is... Okay, so here it would depend if we're allowing for negative numbers under even root radicals. And I mean, if we are, then we can do this. Just positive 2i. There's no, this isn't a, this is a principal, we're given this, the principal square root. There's one output that comes out of that. Okay, k of 8. Principal square root of 9 is just 3. And it makes sense. We couldn't have multiple outputs. It wouldn't be a function, right? Okay, g of t. We're just replacing x with t. That's it. This might seem trivial, like what's the point of this? It's just, you're going to get a sense of why it can be useful to as you go through calculus, as you learn more about functions, it's useful to be able to, it's like you have this on the shelf, this g of, well, no, I didn't do that right. This is 1 over t. You have this on the shelf. You can pull this off the shelf and input whatever you want into it, different parameters, combine this with other functions. Okay, k of x plus h. So we've got x plus h plus 1, and that's it. F of a plus 4, so replace x with a plus 4. Now replace x with a plus 4. But now here we can simplify this a little bit more. So a squared plus 4a plus 4a plus 4 times 4 plus 3a plus 12. Okay, we've got a squared plus 8a plus 3a plus 28. Okay, g of 0, so 1 divided by 0. No, there's no output here. Function doesn't exist here. Okay, f of x plus h. We've got... So we can simplify this. X squared plus hx plus hx plus h squared plus 3x plus 3h. So we've got, let's see, x squared plus h squared plus, I guess we could do 2h plus 3x plus 3h. There we go. Okay, so now for each of these, we want to evaluate f of x plus h and simplify, similar to what we just did in the previous problem. So f of x plus h is going to be minus 4. Just replace the x with f of x plus h, or with x plus h. All right, now let's just simplify. So we've got minus 4 x squared plus hx plus hx plus h squared minus 5x minus 5h plus 2, okay, minus 4x squared minus 8hx minus 4h squared minus 5x minus 5h plus 2. Okay, so let's see. We've got minus 4x squared minus 4h squared. And let's just do minus 8hx minus 5x minus 5h plus 2. Okay, so here f of x plus h is 7 minus 3x plus h squared. So 7 minus, then we've got 3x squared plus hx plus hx plus h squared. So 7 minus 3x squared minus 6hx minus 3h squared, and there we go. Okay, so f of x plus h, we've got x plus h cubed plus 2 times x plus h minus 5. So, okay, you have x plus h times, and then x squared plus hx plus h squared, and then plus 2x plus 2h minus 5. Okay, so x cubed plus 2hx squared plus h squared x plus hx squared plus 2h squared x plus h cubed plus 2x plus 2h minus 5. Okay. So let's see. We've got x cubed plus h cubed. So those two are accounted for. Then let's bring the x squared terms together. Okay. Now let's bring the x terms together. Okay, plus 2h minus 5. Okay, so now if we're dealing with this function here, remember a function or a relation does not have to be an equation. It's any set of ordered pairs. So this is a function. There's no input that maps to the same input mapping to two or more separate outputs. So, okay, what's f of 9? Let's evaluate this function at 9. Well, the input is 9, so the output, f of 9, is equal to 7. What's f of 3? F of 3 is equal to 4. For what value of x is f of x equal to 6? So we're solving the equation f of x is equal to 6 for x. And you could see that potentially there could be more than one answer to this question, potentially. Because you could have separate inputs mapping to the same output. So in this case, there's only one output of 6, and that corresponds to x is equal to minus 1. For what value of x is f of x equal to 3? There's only one output of 3 here, and so the answer is 2. But for a question like this, there could be multiple answers.